Let's go ahead and take a look at an overview of our class. So some of the topics we'll be discussing is, of course, we'll start with our introduction. So we'll be setting up a virtual machine, so a real Linux operating system running on your machine. Even though you might have Windows or Mac right on your computer, it is possible to kind of share those resources to build a smaller virtualized machine. So we'll talk about how to do that. Make sure you do that as early as possible, right? Do this week's lab at your earliest convenience. Because if you do run into issues, right, and a lot of us do, I'll be able to help you out. But of course, that takes time, right? We have to meet, we have to troubleshoot together, we have to try different things. So get that started as soon as possible so that you don't fall behind in the class. And then, of course, we are going to discuss navigating the bash shell. So that's where we're going to be typing in our commands for the duration of this class. We'll discuss file management, just like you have files in Windows and Mac. You save your photos, important documents. You can do all the same things, right, in Linux operating system. But we're not going to be using those buttons, right, those icons, that nice graphical user interface. We'll discuss those terms later on. We're going to be using commands, right, to do everything, which can feel a little daunting, but we'll do it together. We'll do it, step by step. And by the end of the class, I promise you, you'll be somewhat of an expert in navigating the shell. Of course, right, to become a true expert, that could take years, right, to learn the all the ins and outs of the Linux OS. But you'll definitely know how to do a ton of things by the end of this class. All right, so file management, users and groups, just like you have multiple users on your Windows or Mac OS, you can have the same on your Linux operating system. Packages, just like you install different software, right? Maybe you install some Adobe products. Maybe you install some social media apps, like on your phone, right? So those are different operating systems. You're installing software, and you're extending the features, right, of your device, of your computer. Well, you can do the same thing, sorry, through Linux packages. And then we'll be discussing file systems, mounting, unmounting file systems. That'll be towards the end of the class, a little bit more advanced. Then we'll discuss one of the coolest topics in our class, one of the most useful ones is shell scripting. So we'll be able to automate all the different commands we learned throughout the class. We'll be able to execute those with just a few clicks. Um, all you have to do is write the script and then execute it whenever you want. Yeah, and it'll do a ton of things all at once. Very, very useful, very powerful skill. So by the end of the class, you'll have all this knowledge, all these skills under your belt. All right, so Linux operating system. Let's go ahead and discuss what that is. Before we do that, we have to discuss hardware, software, and operating systems, right? I've used this term uh, throughout like this video, right? And you maybe don't know what I'm talking about. If you did take my 101 class, by the way, this would be really familiar to you. You'd have tons of knowledge on this already. So if it ever feels overwhelming, right, it's definitely a good idea. Take a step back and maybe consider taking the 101 course. All right, so what is hardware? Hardware is the physical parts of a computer. So these can be internal, could be processing hardware, the part that performs calculations. It could be storage hardware, the part that actually stores data, right? That could be system data, things that make your computer run, or that could be, your personal files like photos, videos, audio. There's communication hardware. It's the hardware that allows you to connect to your Wi-Fi router at your home or at school. Um, and then, of course, there's also other input-output devices, such as like screens, speakers, and so forth. All right, so what is the application software? Well, that's software that, so it's different than operating software, I should say that. We'll discuss that in the next slide. So it's software that provides instructions to the computer. These applications, software programs, these are all synonyms. Executables, another synonym for software. They're typically installed on a computer before they can be used. So just like you install maybe software to be a programmer, right, to make your own apps, or maybe you install software to edit videos. Maybe you install software for email, right, for productivity. Those are all examples of application software. So software that allows you to execute a certain task on the computer. So there's different categories of application software. Some of the major ones are productivity ones. Those are the boring ones, right, that we use for business and school, Word, Excel, PowerPoint. Then we have some that we're all really familiar with, which are internet browsers. That's Chrome, Firefox, Edge. And then I'm sure a lot of, especially the young people in our class, very, very familiar with social media. I mean, at this point, it's ubiquitous, right? It doesn't matter what age you are. You're probably on at least one of these platforms, one of these application softwares, such as like Facebook, Instagram, WhatsApp, Twitter, and TikTok. All right, got a little bit of a lag here. Just bear with me. All right, so what is an operating system? So we've discussed application software. Well, we also have something called system software. Another term for it is an operating system. So this is a special type of software that manages the interactions between the computer hardware and the software resources. So it's kind of the middleman between your hardware and your software apps at the top. Without the OS, it'd be really difficult for software to communicate and work with your computer. Back in the day, whenever they wrote new software, they had to write it specifically for every single computer. So this kind of layer of abstraction makes it easier for people who want to create new software. They don't have to worry about all the different hardware, right? How much CPU usage do I need? If I need to access the camera, if I need to access your microphone. All of that is facilitated by the operating system. So make sure that your hardware runs smoothly and also makes it easier for your application software at the top to work with the hardware. So it manages all the hardware parts of a computer, including power consumption, processing units, storage, security networks, and file systems. So it does a lot for your computer. We're not going to go into detail, right, of those terms. Again, if you ever feel overwhelmed, right, in these first 2 weeks of the class, I definitely highly recommend you take our 101 class here on campus. And I do teach that every semester. All right, so history of Linux operating system. So before we actually talk about Linux, right, I always like to go through the history, right? Get familiar with how it came to be. And before Linux was actually something called Unix. So this is the predecessor to the Linux operating system. So Unix was developed in the late 1960s at AT&T's Bell Labs. So it was a popular system for servers and workstations. So this is a specialized type of computer. Again, something we covered in our 101 class. So it offered portability, multitasking, and multi-user capabilities. For example, the very first Microsoft operating system did not achieve multitasking. You could only run one application at a time. So if you try to run maybe Photoshop and your Chrome browser at the same time, your computer would crash. So multitasking is another thing that the operating system facilitates. So Unix is the predecessor to Linux. Unix design significantly influenced development of Linux, including its file system and its command line interface. Yeah, not sure why getting so much lag. We're gonna just bear with me. All right, so development of Linux. Let's see. So early Linux version. So they actually have one of the early Linux versions here on this floppy disk. In 1991, a Finnish computer science student. So they're actually a student at the time, Linus Torvalds, began developing the Linux kernel as a personal project to create a free operating system that resembled Unix. So it's just a project he did for his personal enjoyment. He named it after himself, right? Linus Torvalds. I probably mispronounced his name the first time. But yeah, Linux is named after Linus. So the first version, Linux 0.01, was released in September of 1991. Again, it was just a hobby project, but it actually attracted attention from developers all over the world. So by the time the 1990s kicked in, right, the rest of the decade, there was massive growth in the community of Linux. So Linux distros are basically different versions or flavors of Linux, if you want to use that term. So what made Linux special is that it's open source. So Linux embraced the principles of open source software. that meant that anyone around the world could view, modify, and distribute the source code. So, Microsoft, right, Mac, for example, these companies, right, they hold their software close to them, right? They don't really allow people to see how every single portion of it works. Um, that's typical of any software company, right? It's their intellectual property, right? They want to make profits off of it. So making it free, right, and publishing it to the internet is not usually the way they do things, right? If again, they want to make profits. But there is in computer science and computer engineering and software development, there is a huge open source community. That means people like to put their code online so that anyone can use it, anyone can change it, anyone can improve it. And that was the case for the Linux operating system. And that's why it's become so ubiquitous, right? So useful. Is because people were allowed to go in, customize it, and make their specialized versions, right, for all sorts of applications. Whether you're running a server computer, right, Linux is perfect for that. If you're doing some really heavy software engineering, Linux is going to be a great choice for you. Now, if you're a casual user, right, of computers, then of course Windows and Mac might be better choices for you. As of late, right, there's now the Chrome operating system for those even more casual users, right? People who just like to web surf and use some really basic applications. So yeah, because Linux is open source, there's a bunch of different versions or distributions, sometimes called distros for short. So a lot of these emerge and they cater to different user needs. There's Debian, which is stable and versatile. Slackware is simple and minimal. Red Hat, SLS is a user-friendly one. So all these Linux versions, a lot of them, what they do is, like Windows, for example, right, has a lot of stuff in it to make it easy to use. Linux kind of strips down those parts so that it's efficient, and maybe it's not the easiest to use, right, but it's definitely going to be really resource efficient. So it's not going to take a lot of power for your computer to run this operating system. Again, there are different versions, right? So it's not entirely the same across different distros. All right, let's see. I might just not do full screen if this continues with the lagging. All right, let's see. So this is actually the Linux mascot right here. So it's Tux, it's a little penguin. So for the original Linux operating system, that's why that's the cover of our class, right? It's actually our Linux logo here. So yeah, Linux continues to grow in popularity beyond the 1990s and today. It's used across various sectors. It's used in cloud computing, mobile devices, embedded systems. Android, the mobile operating system, is actually based on Linux. So yeah, a lot of the different technology used today still relies heavily on Linux. And the higher up you move, like in the computing ladder, right? Once you move to some serious like engineering, some serious tech companies, Linux is going to be all over the place. So today, thousands of Linux distributions exist, catering to diverse user needs from server environments to lightweight versions for older hardware. So the modern Linux operating system. So now we've discussed the history. Let's talk about Linux in its current state. So again, Linux is an open source operating system kernel that serves as the foundation for a variety of different operating systems. Remember, those are called Linux distros. The kernel, that's just the core component of an operating system. It's the interface between, again, the hardware and the higher up application software or software applications. So there are graphical user interfaces for a lot of Linux distros, but the best way to interact with it is a command line interface. So just to give you an idea, when I'm navigating to, for example, my files, I can simply just go to my file explorer here. I can see my videos, for example. Now, if I want to do that on Windows and Mac, right, I get all these nice little icons. I get these visuals. That's a graphical user interface. Now, in Linux, the best way to work with the operating system is actually through a terminal. And these terminals aren't unique to the Linux operating system. As you can see, Windows has, for example, the PowerShell terminal. So I can type in commands here. Let's see, ls. So it's going to list all the directories in my current files and directories in my current directory. So directory, another name for a folder. We'll discuss that though as we move along in the class. But yeah, this is command line, and this is how we're going to be interacting with our operating system. So I'm on Windows right now because I'm working on this presentation for y'all. But just know that we're going to be mostly using the CLI on Linux. Of course, we got to have our Linux operating system set up first. All right, so common uses include servers. And because it's lagging, I'm actually going to not go with the full screen presentation. Let's see. So yeah, this works just fine. All right, so let's continue. So what is the Linux OS used for? Common uses are for servers. So it's widely used as a server OS due to its stability, security, and performance. Again, it's a really efficient, lightweight operating system. So when you need all the power of your computer, right, for server tasks, servers are kind of the computers that run the internet. They're the reason you're able to get, your friend's social media feed, right? Their likes, your likes. When you jump onto a website, for example, and you're able to see all the resources on the website, servers are kind of the backbone of the internet. So yeah, many web, database, and file servers run on Linux. Desktops. So many distros are designed for desktop use. So I'm running on a desktop computer right now. That's a computer designed right for your home use. Not as portable as a laptop, right? It's gonna have usually those towers and those fans and all the different components inside. So yeah, it provides user-friendly interfaces also for your desktops. There's embedded systems. So we're talking about really simple computers. Those are computers used in routers and smart TVs, cars. So maybe simple is not the best word, but really specialized computers. In your TV remote, right, there's an embedded system. So a lot of embedded systems do rely on the Linux operating system. Again, Linux has that advantage of being really lightweight, so it's not going to be bloated with all these like extra features. Just really what you need. So when you're working with computers where resources matter, efficiency matters, Linux is the way to go. Software development. As a software developer myself, working as a full stack engineer, as I mentioned in my introduction video, I can tell you I use the Linux operating system heavily, whether that was for scripting, for running different applications, for interfacing right with cloud computing. Linux was definitely the way to go. So if you're going to be a programmer, it's extremely useful to take this class. All right, let's see. And finally, let's set up our lab. So we're going to set up our environment. We're going to have a real Linux operating system running on your computer. And hopefully you don't run into many issues, right? But if you do, I'm always here to help out. And I do put some troubleshooting tips in the lab. So that's it for this lesson. Let's go ahead and jump into our environment setup. So that's coming up next in this series.